Think math.
Take the quadratic x squared minus 4x plus 13 equals 0. Its two roots are 2 plus 3i and 2 minus 3i. Look at them. The real parts are identical, and only the imaginary parts carry opposite signs. That is no accident. As long as every number attached to x is real, complex roots always arrive in pairs like this. Why should that be? Look at the quadratic formula again. Both roots share the same denominator, 2a, and the same minus b on top, and the discriminant d sits under the root. Now suppose d is negative. Then the root of d is no longer a real number. It becomes the root of negative d, multiplied by I. So each root is the same minus b over 2a, plus or minus the root of negative d over 2a, times I. The front part is shared by both roots, and only the back changes sign. That is exactly what a conjugate pair means. Let us check it from the other side. Last time we saw that the sum of the roots is minus b over a, and the product is c over a. If a, b, and c are all real, then the sum and the product must both be real as well. Now suppose only one root were 2 plus 3i, and the other were a plain real number like 3. Adding them would leave 3i sitting there, so the sum could never be real. The only thing that can erase that imaginary part is its conjugate partner. That is why the pairing is forced. Let us check with numbers. Take x squared plus 2x plus 5 equals 0. Here d is 4 minus 20, which is negative 16. Negative. Solving it gives negative 1 plus 2i and negative 1 minus 2i. A conjugate pair again. The sum is negative 2 and the product is 5. Both are real. The partners have canceled each other's imaginary parts. Why is this useful? Because knowing one root hands you the other for free. If a quadratic with real coefficients has 3 plus I as a root, then without asking, the other one is 3 minus I, and you can rebuild the equation itself. The two roots add to 6 and multiply to 10. The number in front of x is the sum with its sign flipped, so negative 6, and the constant is the product, 10. The original equation was x squared minus 6x plus 10 equals 0. One condition, that the coefficients are real, was quietly pairing up every complex root all along. A sip of math every day here at Think Math.